Now, A is 300 meters due west of B. The velocity of A is 2I minus J meters per second. The velocity of B is minus 2I plus 2J meters per second. Find the velocity of A relative to B. Okay, so once we define once we define phi AB. Phi AB is phi A minus phi B. Now, phi A being 2I minus J and phi B being minus 2I plus 2J. Then 2I minus minus gives me 4I. Minus J minus 2J gives me minus 3J. So 4I minus 3J for velocity of AB, phi AB. Okay? There we go. Now, find the shortest distance between them on their subsequent motion. So, what we're going to have here is we're going to have them displaced. A is due west of B. Now guys, which one of them is stationary when we're talking about phi AB? Which one of them is deemed to be stationary? B. So B is stuck to the spot. And now we're going to write down the velocity of A relative to B. Now, this direction here, 4I minus 3J, that's 4 to the right and 3 down. It's a southeasterly direction, okay? So what we're going to do is we're going to find out the angle X, such that tan X is going to be, what is tan X going to be? Tan X is 3 over 4. What I'm going to do, guys, is I'm just going to complete the triangle. It's a 3, 4, 5 triangle. Is everybody okay with that? Just do Pythagoras' theorem. It's 5, okay? And what we're going to find out then is that cos X is going to be, anybody? Adjacent over hypotenuse. And then finally sin X, opposite over hypotenuse, 3 over 5. Okay. It's the same thing as finding the angle. If you find the angle, you're more or less finding the, the only reason you find the angle is to use it to find, cos off that angle. We're better off just with the fractions anyway. But look, nonetheless, I'll just tan inverse, I'll tan inverse 3 over 4. And there you go. It's in radian mode, so if you ever see you getting a weird answer, just press shift, set up, number 4 for number 3 for degrees, and then press equals again, and you get 36.87 degrees. So 36.87 degrees is X. Anyway, now what happens next is we're going on our relative path, okay? And our relative path takes A directly by B. So here it is here. A is travelling by B relative to each other, because B is stuck to the spot. We're now asked the shortest distance. What's the shortest distance, guys? Sorry? Go 90 degrees, okay? So what we're going to do is we're going to get this here, then we're going to make sure it's about 90 degrees around here. This blue line here is D. Now how do we find out what D is, guys? We know the green line to be 300. We know this to be angle X. And we know D is here, and that's 90 degrees. So, what function should we use? Sine, cos, or tan? So, sine X is D over 300. And we know that D over 300 is 3 over 5. D therefore is 3 times 300 divided by 5. Anybody know? Anybody know? 900 divided by 5? 180. Alright, 180. Okay, so it's 180 meters, okay? So, why do we always do that? Now, what we have next is, this can take a hike. It was 3i minus 4j anyway. Now, we know that that's 180. The next question asks, the length of time to remain envisioned if the visibility is 225 meters. Remember from earlier that it was 4 across, 3 down. Is that right? Is everybody happy with being 4 across, 3 down? So we did Pythagoras' theorem. We found out that was 5. So every second, says meters per second here. Every second it's going 5 meters down at a direction of east 36.87 degrees south, or angle x. Okay, that is angle x. Okay. Now, what we're looking at here is we're looking at forming a triangle. Okay, the triangle in question will be represented in green, and what we're going to do with this. Wait a minute, it's not a straight line. Okay, show this again. Here we go. So the angle in question, it has to be 225 meters away. So at the beginning of this, you're located here. You're 300 meters away from B. At the closest point, you're 180 meters away from B. So there's a point at which you will reach 225 meters away from B, and then you'll get closer, and then at the end you'll also be 225 meters away from B. So we want to figure out what is the length of this region in here. Once we figure out the length of this region in here, we divide it by 5 to figure out how long we were in that region for. What we can do next is we can form what we're going to form. We are going to form a triangle, and it's going to be an isosceles triangle because these two lengths are the same. So what we have is these two lengths being the same, and we know that this here is 180, and we also know that the visibility is 225. So what I'm going to do is I'm going to use Pythagoras' theorem to find out the length of here to here. Okay? The length of here to here is going to be x squared, I would call it x. X squared equals 225 squared minus 180 squared. Will anybody tell me what that is square rooted? 225 squared minus 180 squared, square root the answer. Anybody have a calculator? Okay. 225 squared minus 180 squared. Oh, what is it? 130. Okay, 135. Okay. Now, guys, what does that mean about 135? What does that mean for the full thing? Twice that, which is? It's 270. And you got to remember, it covers a relative distance of 270 meters when they're within 225 meters of each other. You divide this distance by 5, and when you divide it by 5, what do we get? 54 seconds. Anybody get that the other day? Yeah? Yeah. Well done. Now, going to move on next, okay? Next one we're going to do number 10. Okay, so if you look at number 10, what we're going to do is we're just going to highlight key parts. Ship A, 200 kilometers west of another ship B. B is traveling due north 10 kilometers an hour. Ship A is traveling northeast 20 kilometers an hour. Find correct 2 decimal places, velocity of A relative to B. Okay, correctly highlight the full question. VAB, VA minus VB. Now, ship B, velocity B is directly north. What does that make it? 10J, going directly north. What it does northeast mean? Northeast. So 45 degrees, that's going 20, and we have y and x. I had to find out what y and x are, adjacent and opposite sides. They're both the same length. Why are they both the same length? Isosceles triangle. So what we're going to do here is we're going to say, okay, cos 45 equals x over 20. X therefore equals 20 cos 45. What's 20 cos 45, anybody?
20 root 5.
What?
20 root 5.
Is it 20 root?
10 root 2.
10 root 2, yeah. Okay. Exceptional on the calculator as always, lads. Now, 10 root 2. Okay. So, what we're going to get here, guys, is 10 root 2 and 10 root 2 here. So, what does that tell us about the velocity of A, lads? Anybody? 10 root 2? I plus 10 root 2 J. Okay? That's it so far. Now, we're going to have next, guys, is just going to rub that out, and we have to find out the velocity of A relative to B. We're still on this question. So, what we're going to get is VAB equals 10 root 2I plus 10 root 2J minus 10J. Now, I see no point in keeping it in surd form, because if I keep it in surd form, I'm just going to have 10 root 2 minus 10, so I might as well put that into the calculator and find out what it is. So VAB, I'm going to round both of them off to maybe, my answer has to be in 2 decimal places, so I'm going to use 3 decimal places until the very end. So it's going to be 10 root 2, 14.142, and then I'm going to have 10 root 2 minus 10, so just take away the 10. And what we get there is 4.142. That's I. 4.142J. Overall, what is this direction? Which way is it going? It's going to the right, and it's going up. So it's a northeasterly direction, okay? Now, ship A is west of ship B. Okay, and then B is the one that's held stationary, which is here. Then you draw the course of VAB, and the course of VAB is northwesterly, as discussed already. Northeast. Okay. Once again, we're going to try and find the shortest distance between them. Shortest distance between them, once again, is this one to this one here. And do we have an angle yet?
Yeah.
We don't have an angle for VAB, we don't. So I need to find information about this VAB. So to find information about it, what we're going to do is do Pythagoras. Oh wait, that's the wrong way around. We're going to do Pythagoras' theorem. And to do Pythagoras' theorem, what we're going to do is go up and across. So it's 14.142 across 4.142. I want to find out how fast it's going for a start. So to find out how fast it is, we got to do Pythagoras' theorem. That one squared plus 14.142 squared, and then square root our answer, and we get 14.736. So our speed is 14.736. I also want to find out what is the angle x here. So I'm going to tan inverse. I'm going to tan inverse 4.142 divided by 14.142. Now what we get here is 16.3 So we're going to do 325. 16.325. Now, this angle here, therefore, is 16.325 degrees. I know that this distance here is 200. And I want to find out what D is. Can anybody tell me how to find out what D is? Huh?
200 times
sine, okay, because the longest side in the triangle is the hypotenuse, which was 200. Okay, so what you're going to do is sine 16.325 equals D over 200. Cross multiply that 200 upwards. And what we're going to get is 200 sine, what's it, 16.325. I don't see the 3 there, see a lot of things there. 56.21 is the closest distance. 22. So D here is now going to be 56.22. Now, find the shortest distance between them. Done. The distance between them 1 hour after they were nearest to each other. 1 hour after they were nearest to each other. Okay? So, what we really need to zone in on is just extending our diagram beyond where it is currently. So we're just going to rub out everything here. Won't rub out that though. Rub out that. Rub out that. Rub out that. Okay? So, the information I'm left with is this here. Okay, this is what I need. Now, what it's saying is, until the current point in time, we've travelled this far and we've stopped here. Now it wants us to continue for another hour. If you look at our timing is in kilometers per hour. So we're going to travel relative to each other, the distance between them 1 hour after they were nearest to each other. Okay. 1 hour after they were nearest to each other, okay, would mean that, this line here continues. We are still traveling. Sorry guys, 1 second. See the yellow line there? The yellow line is the initial displacement. We were travelling along, B is fixed. So we're A, and A is travelling relative to B. So we're stopped up here. Because remember, the relative path is going diagonal right up. So what's actually happening is we're going up this direction here. And now all of a sudden we're stopped here. This is when we're at our 56.22. Now all of a sudden what we have to do is we have to continue on our path. So what we're doing is we're continuing all the way up here. Now we're only continuing a short amount more. How much further do we go? Can anybody tell me? We only go 14.736 more. Okay? Now, it would be great if we knew this distance from here to here. If we knew this distance here, that'd be great. Does anybody know how to get that distance? We can use Pythagoras, or we could use cos. So we could say cos 16.325 equals, call this y over 200. So what is 200? Somebody in the calculator, 200 cos 16.325. Anybody tell me what y is?
Is it 200 over y?
No, adjacent over hypotenuse. Hypotenuse is 200 and adjacent is y. Y is actually a smaller side than 200.
Oh,
anybody know?
191.936.
191.935. 191.935. 9.365, yeah?
Yeah.
So let's call it 937. Okay? Now lads, on our new triangle, if I made a brand new triangle, okay, and this triangle encompassed this region here, a straight line from here to here, and all the way across. Do you see the yellow region now? Do you see the see this region here? The new distance it's away is this distance here. Okay? So if I construct a new triangle, where the new triangle looks something like this, what the question is specifically asked me is, it's asked me the distance between A and B. A is now located up here. B is fixed in its position. This is the starting point of A. Now it's all the way up here. And I need to find this distance here. I know that this here is 200. I know that this is the angle 16.325. And I also know that this length here is going to be what, guys? It's going to be 191.937 plus or 14.736. So what's 191.937 plus 14.736 in the calculator, please? We know?
206.673.
206.673. Have you guys done cosine rule or sine rule yet? No. You haven't done trigonometry yet? Alright, so let me show you something before I'll do it here. Okay, so what I now need to show you is we're looking to find out what is this distance here. Yeah?
Could you not just use Pythagoras with the 14.736 and 56 to get it to the new one?
You could. That's actually quite good. That's actually a good way of doing it without doing the cosine rule. I might actually just take that way out now. Actually, I'm supposed to show you the sine rule. I'll show you the sine rule and cosine rule in a few minutes, okay? So guys, what we have here is you could actually do it that way out. So what we could do instead, it's a very good idea. What we could do instead is we could zone in on this triangle here in blue, and what we could do is we could do this here, and this down, and we could say that's 56.2, that's 14.736, and it's a lot faster. We actually didn't need that one then that way. This is actually faster, okay? And then what we could have found out was what is this distance here using Pythagoras' theorem. So we could say that x squared equals 14.736 squared plus 56.2 squared. Will somebody put that in the calculator then square root the answer?
58.0998.
58.0998.
Yeah.
So 58.1. Okay guys. Shh.